Let's look at another example of finding the area under the curve, finding what percent of people are in a certain part of a curve, right, in a normal curve. So we're dreaming about Chico Hot Springs because, we're all quarantined still and cannot go there. So we're going to think about it. Well, the amount of time people spend at Chico Hot Springs is normally distributed with a mean of 67, a standard deviation of 17 minutes, which means the average person spends about 67 minutes at the hot springs, and it's spread by about 17 minutes on either side. Okay. Find the probability the randomly selected person at the hot spring stays longer than 85 minutes. Now remember, if this number 85 is exactly 1, 2, or 3 standard deviations away from the mean, I could just use the empirical rule and I'm done, right? I can just say, well, 1 standard deviation away from the mean is 68% of people, and so on and so forth, right? But in this case, 85 is not exactly 17 away from 67, or 2 standard deviations away from 67. So we have to calculate the z-score and then use our calculator to find it. And actually, we don't actually have to calculate the z-score to put it into our calculator, but it's not a bad habit to get into, just understanding where this is going to fall on the curve. So to calculate the z-score, we take the value, 85, and we subtract the mean, which is 67. And that's how far away they are from each other, because subtraction is just finding the distance between 2 points. And then when we divide by the standard deviation, that tells us how many standard deviations it is away from the mean, not just how many numbers, right? So we're going to go put that in 85 minus 67 divided by 7. I want you to remember to use parentheses around the top stuff so that because our calculators are pretty good at order of operations, and they would divide first. So make sure you put parentheses around, and we get that this has a z-score of 1.058. So basically, this is a little over 1 standard deviation away from the mean, just a little bit above. Okay, so now we want to figure out what is the area under the curve, or what number of people spend a certain amount of time. So let's go back to our question and figure out what they're asking. Find the probability that a randomly selected person at the hot spring stays longer than 85 minutes. So what does that mean? So here's our curve. Here's our normal curve. And we've got 85 minutes. It's slightly bigger than 1 standard deviation away. And we want to find the probability that if we picked one random person at the hot springs, that they would have spent more than 85 minutes at the hot springs. So we're going to say we're looking for the probability that we're going to pick one of these people. So how many of our people are actually in there, right? There's 100% of our people are somewhere under this curve, right? If I took a selection of all the people at Chico Hot Springs, 100% of them would go somewhere. Some of them would be here and some of them would be here, but 100% of them are under the curve. So I want to see what percent of the people are in this purple spot. So we're going to use the Normal Cdf function, which is on your TI-84. And we're going to have our lower bound is 85 and our upper bound is going to be like a huge number, right? We want to go from 85 basically to infinity. And we want to figure out how many people are going to be in this area. So we're going to go to distribution, which is second, and then the vars button, because see above the vars you see distribution. And again, remember we're talking about normal distributions, so we're going to do normal CDF. Our lower bound, we're going to do 85. Remember, we're looking from 85 to positive infinity. And our upper bound is just going to be like a huge number. So you can just type in a huge number if you want, or you can, do it in scientific notation, but it's easier just to type a 1 and a bunch of zeros, because we're looking at 85 to like, no one spends this long at a hot springs, okay? There's nobody that spends that long. So this number is a safe, it means infinity. It means like the highest possible person we could get, okay? And now remember mu, this little u, is our mean, and then our standard deviation of 17. And then we go down to paste. All right, and this tells us the area under the curve that we were looking for was 14.48. Let's see there, right here. 14.48. It was 0.1448, right? And then remember, this is a percentage. This is a percent, so we're just going to move the decimal place. So this is actually 14.48% of people spend 85 minutes or more at the hot springs because 14% of the people in this distribution are going to be in this purple area above 85.